Welcome to The Explainer. We're all about breaking down huge topics into ideas that just click. And today, we are pulling back the curtain on something you use literally every single day, but maybe don't fully get, the internet itself.
So let's start with something super simple, a click. I mean, you do it hundreds of times a day without even thinking about it, right? But that one tiny action, it kicks off this incredible, super fast conversation between computers that could be on opposite sides of the planet. And that feeling, where information just appears instantly, it feels like magic. But it's not. It's actually one of the most amazing pieces of engineering we've ever come up with. So we're going to break it all down, step by step, and show you the genius that's hiding in plain sight. All right, to really get how the internet works, we got to start with the physical stuff, the foundation. And that means we need to clear up something a lot of people get wrong, the difference between the internet and the web. Believe it or not, they are not the same thing, not even close. Okay, think of it like this. The internet, that's the actual highway system. All the physical roads, the bridges, the tunnels. The World Wide Web, all the websites you visit, that's just one kind of car driving on that highway. Your email, your Netflix stream, your online games, they're all just different cars on that exact same road. Okay, so let's follow that click of yours on its journey. The very first thing your computer has to do is figure out, where am I going? It needs an address. But it's not the kind of address you'd write on an envelope. You know how you don't really memorize phone numbers anymore? Your phone just has them saved. Well, the DNS is basically that, but for the entire internet. Your computer has no idea what myfavoriteblog.com means. So its very first stop is the DNS, which acts like a giant phone book and looks up the real numerical address for that site. All right, so now your computer has the address. The next step is to package up your request so it can actually be sent. See, the internet doesn't just send one giant file all at once. It's way smarter than that. It works a lot more like a postal service. And that IP address, it is absolutely crucial. Every single thing connected to the internet, your phone, your laptop, a giant server somewhere, it has one. It's the unique street address that makes sure your digital mail gets to the right digital house and not, your neighbor's. So instead of trying to mail an entire encyclopedia in one box, the internet chops up your requests into these tiny little pieces. We call them data packets. It's just a way more efficient and reliable way to send things. But wait a minute. If you're sending a message as a bunch of separate postcards, how do you make sure they all get there and in the right order? Well, that's where a set of rules called TCP comes in. You can think of it like a promise. It basically guarantees that all the packets arrive safely, and it gives the other computer instructions on how to put them back together. And if one little postcard gets lost in the mail, TCP notices right away and just asks for it to be sent again. Pretty cool, right? Okay, so our digital postcards are stamped, addressed, and ready to fly. But how in the world do they actually travel? How do they get from, say, your laptop in Ohio to a server in Tokyo in literally the blink of an eye? Yeah, it's so easy to picture the internet as this cloud, right? Something ethereal. But the reality is the exact opposite. It is a massive physical spiderweb. Your data isn't just floating around in the air. It's physically racing through a very real network of actual cables. And get this is wild. Over 95% of all international data travels through fiber optic cables. We're talking about these huge bundles of glass threads, and a ton of them are just sitting on the bottom of the ocean. Yeah, it really is the invisible backbone of our world. These little strands of glass are thinner than a human hair, and they carry our information as tiny pulses of light. And they're traveling at, well, basically the speed of light. So as your little packets are zipping along these cables, they keep hitting these checkpoints called routers. A router is like a super smart, super fast mail sorter. It takes one look at the IP address on your packet and instantly figures out the best way to forward it. And because there are so many different paths a packet can take, if one road is blocked or has a traffic jam, the router just sends it a different way. That's what makes the internet so incredibly durable. So after hopping from router to router, maybe crossing an ocean or two, all those little packets finally arrive at their destination IP address. They've made it to a very powerful computer we call a server. And probably the best way to think about this whole exchange is like a restaurant. Your computer, you're the client sitting at the table placing an order. The server is the restaurant's kitchen. It gets your order, cooks up the web page you asked for, and gets it ready. And the network, all those routers and cables, that's the waiter, who delivers that finished dish right back to your table, or in this case, your screen. Okay, so now the server sends the web page you asked for back to you. It does the same thing, chops it up into packets, and sends them on the return trip. And this whole back and forth process is where you can really see the true genius of how this whole system was designed.
See, the internet isn't just one giant, messy system. It's actually a beautifully organized stack of technologies. You can picture it like a set of building blocks or layers. Each layer has a very specific job, and it doesn't worry about any other layer's job. When you send something, the data travels down the stack. When you receive something, it travels back up.
And honestly, this layered design is the secret sauce. It's the whole reason the internet works so well. The top layer, where your browser is, doesn't need to have a clue whether the bottom layer is using Wi-Fi or physical cable or something we haven't even invented yet. And that flexibility is what let the internet grow and adapt and become this thing its creators never, ever could have imagined.
So the next time you click a link, just for a second, remember that incredible journey. It's not magic at all. It's this beautiful dance of phone books and postal services and lightspeed superhighways. It's a whole system of rules and layers all working together perfectly to connect us. And it kind of makes you think, right? As this invisible system keeps growing and changing, who gets to write the next set of rules?